Hi, let's solve today's daily challenge, that is bitwise and of numbers range. In this question, we are simply given two integers left and right that represent the range, right? So we are just given a particular range and we need to return the bitwise and of all the numbers in this range inclusive. Right, so here we are given left is equal to 5 and right is equal to 7. You have to tell what is the and bitwise and of all the numbers from 5 to 7, that is 5, 6, and 7. So it is 4, so that is what we have returned. Then here it is 0, and from here you can see it's 0 again. Now, how we have to like solve this question? So as the question is like pretty straightforward, it's like just print the bitwise and of all the numbers. But if you see the constraint, that is how many numbers you're given, so you're given from 0 to 2 raised by 31. So that is a very big range and you'll get TLE if you simply do the brute force. That is just loop through these left to right numbers and just calculate the bitwise and. So how do we have to go about this problem? How do we solve this? So let us come onto the whiteboard and let me take the first test case. Left is 5 and right is 7, right? So the numbers that you have to return the and of is this, right? 5 and 6 and 7. This is what you have to calculate. Now in such questions, whenever you're given a range, right, and whenever it is, if a question is of bit manipulation, it's very important that you simply write the numbers in their binary format. So that makes the problem easier because then we can observe the patterns and we can try to like understand what's happening within those bits and try to come up with an answer, right? So here also, as we know, we have to kind of deal with bits, right? And because a simple and operation from left to right is going to give us TLA because the constraints are too high, so we'll simply write all these bits down and try to figure out what we can do with them, right? Okay, so for 5, 5 is represented as 101, right? And 7 is 111 and 6 is 110, right? So we have 101, 110 and 111. Now see, what is AND operation, like what AND operation does? So we know that AND operation simply takes two bits, and if both the bits are 1 it returns 1, otherwise it returns 0 if any of the bit is 0, correct? So that means here if I see, right, here if I see there is this 0 bit, so you can see that no matter what, when the AND operation will be performed, this bit is definitely going to be 0. Similarly, this bit will be 0 and this will be 1 because all the bits are 1 here. So the answer you get is 4. All right, so there is first thing that I can see here, that is when we have zeros, right, we definitely are going to unset the bits that are placed there, correct? All right, so now I've understood it. But like, can we solve it using this? Then again, we are like kind of have to iterate through the numbers and figure out where the set a bit is set and where the bit is not. Again, in this case also we'll get TLE. What else we can do? So there is this one property of in bitwise in bit manipulation, and it is when you do and n minus 1, right? N can be any number. When you do bitwise of n and n minus 1, you unset the last bit, right, set bit of n. Okay, so what do I mean by that? Let us see. So if I take, let's say I take a number, let's say I take 7 only. Okay, so I take 7 and I'm saying you have to AND it with 6, that is n minus 1, so 6 is 110. Now I'm saying if I simply AND this, right? If I AND this, what will happen is the last set bit of 7 is this, right? It will get unset. So I'll get 110. So it's true that this bit got unset. So this is a property that you should be aware of. Now, how we are going to use this particular property to solve this question? See, all we have to do is we have to go and see the given range, and we have to calculate the and, right, of all these numbers. And we have understood one thing, that wherever 0 is present, right, that bit of each and every number is definitely going to get unset, right? So we can use this property, right? We can use this property. Now why can we use this property? The reason is, see, let me first make things clear, right? What we will be going to solve or doing, what we will be going to do to solve this question is we are going to use this property. How are we going to use this property? So what I'll do, I'll take the right, okay? I'll take the right number. I'll do this, right? And I'll calculate right and right minus 1. I'll calculate this. Then I will get a number which will unset the last bit of the right number, right? Let me write all the numbers from 0 to 10, okay? So 0 0 0. Okay, so these are from 0, 1, 2, 3, 4, 5, 6, 7. So what I'm saying is you have to take the right number, okay? So I'm not caring about what is the left number. I'm only concerned what is the right number. And then we'll try to iterate, okay? So let's say I have 7. Okay, let me take 8 and 9. Let's take up to 10 only. So we'll get 1, 0, 0, 0. 1 and 10 would be 1010. All right, so now we have all the numbers, and now I have to calculate, let's say 10 and 3. So this is the range, right? So I'm saying forget about the left for now, just use the right. And using right, just keep calculating this. Let's do it, right? So as you see that we have 10 as the right, so 10 and 9 I'll do. So what I'll do, I'll calculate 10 and 9. So I'll unset the last bit of 10. That is this one. So this would become 1000. That is 8. So I will come here, right? So I'm iterating, right? I'm iterating up to some condition, and we do not know that condition yet, right? But we are iterating. So after that, my right would become, so I'm storing this value inside of right only, okay? So my right would become this 8. After it becomes 8, see, now I have to go to 3, right? Let's try to unset this bit also. So after I unset this bit, right, so 1 get unset, so we'll go to 0, right? Now I'll be having 0. So obviously now we cannot go anywhere else. So what will be the answer that we would be getting in this case? Okay, let us see. See, in this case, the answer would be 0 only. And the condition up to which we will be iterating is that right should be greater than left, right? If let's say right becomes less than left, then obviously that is not the range that we are trying to iterate to. Now how is it going to give me an answer, right? Okay, so we have 0 stored inside of our right value, right? And after we come here inside of this condition, I can see that okay, now right has become less than left, so that means we have to return this 0. So let us see, in this particular range, what is the answer that we are going to get? So definitely, because all these three are 0, so the last three bits are going to be 0 only. And here, because 3 is also involved, so here you can see these are all 0. So 0. So definitely 0 is going to be our answer. So that is what we have returned. So here you can clearly observe that we are going to get 0 as an answer. Now what if I had to simply iterate to, let's say, 8, right? If I had to go only up to 8, then what would happen? What should be the answer in that case? What will I return, right? So in this case, my right, see, I am not using right equal to left, I am only using right greater than left, right? So in the last iteration, the value became 8, right? It became 8. Then I'll go here and I can see that now right is not greater than left, it is equal to left, it's not greater. So that means I will have to return this value, and you can also see here that this is the value that is going to be returned. That is 100, because these three are 0 and this is 1, so 1 for all these three. So that is what we are going to return. Let us try this out for this test case. Okay, so in this test case we are given 7 and we are given 5, right? So this is the range that we are given. Now the answer we already know, it is going to be 110. But let us try to calculate using this, right? So if I use this property, so I know 7 is this, 6 is this, what am I going to get? I am going to get 110. All right, then what I'll do, I'll go to this 4. But now I can see this 4 because my right has become more less than left. So I'll quit from this loop and I'll return this value. So now you can already see here that, okay, here we are actually going to get 110. Okay, so we are going to get 6. We would come here, not to 4. Then when I'll do 6 and 5, that is 101, I would get 100, correct? And then I will get 4. So now you can see 4 is less than your left, correct? That is 5. So that means you have to quit from the loop and this value will return, that is 4. So in this case also it's working. So I hope now you are able to understand how we are using this property and how we are solving the question. And now you might ask that when we are trying to use this property, aren't we kind of trying to, go linearly? But if you see, we're not going linearly because we are directly unsetting a bit, right? Using this property, the last bit of n, and that has to be unset because we know we have to AND it with the previous value, right? Because let's say even if my range was 8 and 9, right? And here it's already given to me in the constraint that they can be even equal or not equal, then also we'll be getting an answer, correct? So that means we are not going to iterate linearly, we are rather going like this, right? We can unset a bit, so we skip all these values, correct? We skipped all these values when we were unsetting 8, right? We unset this particular bit, so we skipped all these values. See, we skipped all these values. So this is how we are not going linearly at all, right? Rather, now let me tell you the time complexity for this. So time complexity you can see here is you are iterating in kind of bits, right? So the maximum bits that you can have is 31 here, right? So if you are having 31 bits at most, you are trying to unset them, correct? So when you do n and n minus 1, you are unsetting a bit, correct? So if even if n is 2 raised power 31, let's say, and we are going from 0 to this particular range, then I am only going up to these 31 bits and unsetting them one by one with each iteration. So in the first iteration, I'll unset this. Second iteration, I'll unset this. Third iteration, I'll unset this. So we are just unsetting these bits, and that means we are simply iterating 31 number of times. So our time complexity will become big O of 31, which is nothing but constant, correct? And already, and space complexity we are obviously not using. We are only taking this particular variable and calculating the AND operation in it only, and it it is going to have the value, right? It is going to contain the value. So that means our space complexity is also big of 1. So this is the time complexity, this is the space complexity. So this is basically how you have to solve this question. And please do remember this property very well, because this was the only property that we were using to solve this question. And the reason we could use this property is that first is you have to calculate right and right minus 1, right? You have to go right and right minus 1 and right minus 2 and up to left, correct? That is how you are going about it. But using this property, you have to also remember that you are unsetting the last bit of n. So if you are unsetting the last bit of n, so you might even skip a few numbers, right, and reach to a bit where that particular bit is unset. So that means you're simply iterating in these bits, right, in these 31 bits, and trying to unset them rather than going linearly. So this is not making you go linearly, rather it is helping you unset the last bit. That was like that is the use of this property, right? That is why it's very very important, very very useful. And obviously this is quite intuitive also, that you are just going from right and right minus 1 and right minus 2 and so on up to left, right? This is what you are trying to do, you're calculating the and of this. But because and operation does what, wherever there is a 0, right? No matter how many ones you have, right, you are going to get a 0 that in that bit, correct? So that is why this property is useful, right? It is helping us skip a few numbers rather than go linearly. So that is about this question. This is how you have to basically solve it, and the code of it is quite easy. As I said, what we are doing is we are simply iterating up to right is greater than left, and just calculating inside of right and right minus 1. That is what we are calculating, right? So that's it, and after this you have to simply return the value that you get from right. So let's quickly run it. So it's accepted. So this is basically how you have to simply solve this question.